This is a lesson over the universe. It is step 4 out of 5 steps that we'll be learning about. This step covers solar system composition, so it specifically focuses on what makes up our solar system. We're going to start with our learning targets. And so the first learning target is that you know that the sun, planets, moons, asteroids, comets, and meteors are components of our solar system. So as you know by now, in order to know something, you recall it or you repeat it back, but you might not really understand why or how something works. Components are parts or pieces, and our solar system is the place where we live. So the Earth is part of a system of other planets, and we orbit a star. So that is what makes us a solar system. The second learning target is that you know what gravity and centripetal force are. So again, knowing is recalling or repeating, stating something back. Gravity is a force that causes everything to fall to the Earth, and it also causes the Earth to orbit around the sun. So we'll get a little bit more into detail on gravity. Centripetal force is very similar to gravity, only it really focuses on our energy orbiting around the sun. The third simple or basic learning target is that you know what density is. And density is looking at more than something's weight or mass, and it's also looking at more than something's volume or the space that it takes up. It's kind of putting those two together. So it's looking at something's mass in terms of the amount of volume or space that it takes up. Now we're going to get into some understand learning targets. So I understand the different characteristics and orbits of the sun, planets, moons, asteroids, comets, and meteors. So when we're talking about characteristics, we're talking about what is it made of. When we talk about orbits, we talk about it circling around another object. So how do planets orbit around the sun, or how do moons orbit around the different planets? We're going to look at Earth's gravitational pull and how it keeps the moon orbiting. So we're specifically looking at gravitational pull, so the force between two objects. And the final learning target is that you understand the sun's gravitational pull holds the Earth and other planets in orbit. So let's really get into some of this stuff. We're going to start off with the solar system components. So I have some pictures here that you can look at. These are our components of the solar system. So just take a minute and take a guess. Look at the pictures. What do you think the components are? Say it out loud, write it down. So go ahead and guess what the different components are, and then I'll reveal the secret in just a minute. Okay, here we go. So the first component all the way to the left, it's that great big ball of hydrogen and helium burning. That's the sun. The next object are planets, so that's on the top right-hand side. And you can see we have some small terrestrial planets and some large gas planets, and we'll get into what those different terms, terrestrial and gas, mean. Another component are moons, and again, that's on the right-hand side. And so we'll talk a little bit about Earth's moon, but some of the other gas planets also have moons, sometimes more than one moon orbiting around them. To the left middle is an asteroid. To the left bottom is a comet or a dirty snowball. And you might see a meteor shower or a shooting star shower on the bottom right-hand side. So those are meteors. These are all objects that you will find in our solar system. So again, it's what orbits around the sun. Solar means sun. It's the system around the sun. So let's talk a little bit about what gravity is. Gravity is a force. And it's a force that when we're standing on Earth, it pulls everything to the center of Earth. And that's because Earth is larger than everything on it. So when we look at gravity and gravitational pull, we're really looking at the mass between the two objects. The Earth's mass is huge compared to my mass. So I'm going to be attracted to the Earth. I'm going to stick to it. There was this dude called Isaac Newton, and this was in the 1600s. He was a physicist and a mathematician, and he came up with this idea of the universal law of gravitation. And so in this idea, he said that when there are two objects in the universe, they're attracted to each other. And that force of attraction depends on two things. It depends on the masses of the object, which is very similar to weight of an object. Weight includes the mass of an object plus gravity. So your weight will change depending on what planet you're on or if you're on the moon, but your mass will always stay the same. And the other thing that this universal law of gravitation depends on is the distance between the two objects. So as we get further and further and further from the sun, there is less gravitational pull. Here's a nice little image of the Earth. And when this guy throws the ball up, it immediately comes down. And notice that it doesn't matter if you're on the North Pole, the South Pole, it doesn't matter what hemisphere you're on, no matter what, because that object, the ball, is smaller than the Earth in mass, it's automatically going to be attracted to not just the Earth's surface, but the center of the Earth. So let's get into centripetal force. Centripetal means center seeking. So it's looking for the center of something. And when we talk about centripetal force, we're talking about a motion. So centripetal force keeps the planets in orbit. It's this motion that helps pull planets toward the sun. According to Newton, so the same dude that came up with the universal law of gravitation, he came up with this other idea that all masses would like to move at a constant speed in a straight line. And so that's this idea of an object in motion stays in motion, or this idea of something called momentum. If you give something a push, it's going to keep moving in a straight line until some other force acts upon it. So with this idea of centripetal force, the Earth wants to move in this straight line because of centripetal force. It wants to move in a straight line at a constant speed, so Newton discovered that. But it's being prevented from doing this because the sun's gravity is also pulling on it. So the Earth is trying to move in a straight line at a constant speed while at the same time being pulled by the huge mass of the sun. And so we say that the sun applies a centripetal force, so it pulls the Earth in a circle or center-seeking path or orbit around the sun. And so here's a nice image of centripetal force. So you can see that the green, the sizes are terrible, I have to admit, but this green circle is the Earth. The black circle, which is way smaller than it should be, is the sun. And so the Earth does not want to be in this path normally. It really wants to just be going straight at a constant speed. But because the sun is so enormous, it's pulling the force of the Earth into the sun. And so that's why there's an arrow that's going from that green Earth and it's pointing to the black sun. And so that is the centripetal force right there. Here's another image. And so this one actually shows you that the momentum or the path of inertia, that's this idea that an object in motion stays in motion. And then we have this opposing idea that the sun is pulling the Earth with the centripetal force toward the sun. And that's what's causing our orbit. So here's another idea that we need to be thinking about, and that's density. And so density is a very, very tricky topic to understand. So this is just something I want you to start thinking about. You'll learn a lot more about density next year. But what density is it's the amount of mass. And so like I said, mass is very much like weight. So it's the amount of mass in a certain volume. So You can see the image on the top here where we have two cups. And in cup A, each of those red dots is like mass. So let's say it's like 1 pound or 1 gram of something. And so look at B. B has a lot more mass in it than A, but they're in the same volume or the same area. We would say that B is more dense than A, or B has a higher density than A. If you were to pick it up, it's going to feel heavier because there's more mass in the same area. It's going to feel heavier than A. So cylinder A has 6 red dots, cylinder B has 24 red dots. Both of those dots are the same, both the cylinders are the same volume, but B is more dense because it has more red dots or mass. Look at the boxes or the cubes below. Which box is the most dense? A or B? Why? If you said A is the box that is the most dense, you are correct. And if you said that the reason that it's the most dense is because there are more red dots or more mass and the volume stays the same, then again you are correct. So density is really looking at the mass of something in a certain area or a certain space. All right, so we're going to get into some objects, and we're going to talk about their sizes, their characteristics, and their orbits. So not only do you need to be able to just list the objects of the components of our solar system, but you need to talk about them a little bit too. So we'll start with the sun. The sun is the largest object, which I've talked about in a lot of other lessons, but not only is it the largest object in size, but look at that. It takes up 99.8% of the solar system's mass. 99.8. Oh my gosh, it just makes me realize how tiny the Earth is. The sun is made up of gases, and these gases produce their own light and their own heat energy. The sun is the only thing in our solar system that produces light. Anytime we see light from anything else in our solar system, it is a reflection of the sun. So for example, the moon, we see light that is reflected off the moon back toward the Earth. The orbit of the sun, it doesn't have an orbit. Everything else orbits around it. So the sun is the center of our solar system. We'll talk about some planets and a moon, and we'll be specific as to Earth's moon. Planets. I've listed all the planets and their sizes. The sizes are in diameter. And so you'll notice that different planets have a lot of different sizes. Venus is very similar to the size of Earth. It's called Earth's sister, Venus. Notice how huge Jupiter and Saturn are. So there are gas giants. And then the really important thing to know about planets is that we group them into 2 different categories. The first category is called terrestrial. And so all the planets that are terrestrial, I put a T beside them. Terrestrial means Earth-like. They're small, they're dense, so they have a huge mass, maybe not a huge volume, but a huge mass. They have a rocky surface and an iron or metal core. Their atmosphere is very thin, so this is the part that's just right above the crust of the planet. Terrestrial planets have very few moons. Earth, as you know, has 1 moon, and there are no rings around terrestrial planets. So that's the first category or group. The second one is gas, the gas giants, or the gas planets. And gas giants are mostly made of gas. So they have a huge, deep atmosphere that's very slushy, so you can't really stand on these planets. The cores are partially solid, so they might be solid or they might also be a liquid or a gas. And these planets, because they are so large, they have many moons that orbit around them. And they also have rings, and rings are debris that orbit around the planets. And so, as you can see, these planets orbit, and they orbit in this order, meaning Mercury is the closest to the sun, and Neptune is the furthest from the sun. So they orbit in this order. Moon's Earth is 3,476 kilometers in diameter, so it's obviously smaller than the Earth, needs to be in order to be orbiting around the Earth. The surface is made of dust and rock, and instead of orbiting around the sun like the planets, the moon orbits around the Earth. And if we were to look at some other moons, they orbit around other planets. The last three objects are asteroids, which sometimes we call minor planets, comets, and meteors, or shooting stars. Asteroids are not, they're smaller than planets. That's why they're called minor planets, but they're still fairly large. They are made of rock, and they're irregular in shape, so they're not round. They look like giant space rocks. You'll see asteroids orbiting all over the solar system. But one thing to know about them is that they concentrate between Mars and Jupiter. And so there's something called the asteroid belt. So as you fly out from the sun and you go past Mercury, Venus, Earth, Mars, and you're trying to get yourself to Jupiter, you're going to have to drive through an entire cloud or an entire belt, a huge distance of these asteroids that are just orbiting around the sun. Comets are relatively small. The head or the coma of the comet is small, but the tails can be very long. Comets are made of frozen gases, ice, and dust. Sometimes they're called dirty snowballs. And they have something called short and long period orbits. And so what that means is comets don't orbit in a circular path, which is very much like the planets orbit. They orbit in something called an elliptical path or an oval. And so these long period comets go way out past Neptune, past what used to be Pluto, past something called the Kuiper belt and the Oort cloud, which are way on the edge of our solar system, far, far, far away. That's where these comets travel to, these long period comets. And sometimes they get lost out there. And so they lose the gravitational pull back toward the sun, and they just keep on going out into another galaxy. So those are the long period comets. Short period comets are ones that come back around the sun every few years. And so, it could be 10 years and they're coming back around the sun, and that's actually considered a short period of time when you're looking at the universe. And the final object are meteors. And so these are actually really small. By the time you see them, they're usually the size of a grain of sand. And meteors are they're space rock that are burning up. And a lot of times this space rock is burning up as it's entering the Earth's atmosphere. And there's a lot of something called friction. And so it's like when you rub your hands together and they get really, really hot, that's what's happening between the space rock and the atmosphere, and it ends up burning up. And so that light that you see is the meteor that's burning up. And their meteors do not orbit. They are randomly burning up in space. And we get to see them. Okay, we're going to get a little bit into gravity. And so we're going to talk about sun's gravitational pull. So as you know, planets orbit around the sun and moons orbit around the planets. The moon orbits around the Earth because the Earth is larger and more dense than the moon. So just like our buddy Isaac Newton said, the universal law of gravity says that objects are attracted to each other, and it's dependent on their mass and their distance. And so the moon is attracted to the Earth because the Earth is bigger and it's fairly close. And it's important to know that an orbit is the path that an object takes as it moves around another object. So here are there are formulas. I don't want you to worry about the formulas. That's something you'll really get into in high school and in physics. They're probably scary looking. But it's important that you know that these objects are really affected by the center of masses and also the distance. And so you can see that top right hand picture here is a perfect example of, I mean, you could look at it as the yellow dot is the sun and the blue dot's the earth, and the sun is a lot larger than the earth, and therefore the earth's the red force arrow is attracted toward the sun. Or you could look at it as the yellow dot is the earth and the blue dot is the moon, and the attraction is the same. So that's sun's gravitational pull. It was a lesson over the universe, step 4, the solar system composition.